as usual, new activity starts with review of some theoretical parts, at least for first 2 weeks, and then some break, and then practical part. For those of you who have some experience with Java already, you may try to complete second exercise by yourself using whatever integrated development environment or not integrated development environment you choose to use. If you have some experience but not too much of it, remember that here from first exercise on my virtual machine I didn't complete everything. I didn't download latest and greatest stable version of Eclipse as one of development environments. So you need to go back here to exercise 1 and review it and go to this link here, and then you can quite safely go to the next exercise and try to complete it by yourself. And after that, if you are not tired and you want to prove your experience, you may go here in link called extra exercises from starting page of these materials and fulfill these instructions. So these instructions will not be explained in details to entire class, but if you have enough experience and you don't need precise guidance how to complete these standard exercises into standard workflow, then you review this project and you can complete required parts in these extra exercises. Some of extra exercises which have quite new different topics may also have web pages with some more detailed instructions for them. Some are just extra work to prove your experience, so from theoretical perspective there's not much new things, only more work to do to prove your experience. So these are my recommendations which you should follow if you have enough experience in Java already and you are not tired and you do not want to be bored during this review about Java. For everybody else who needs more guidance, here we will review general principles how Java was built, designed, and how it runs. We will not touch in details Java language itself, like its syntax, how it is written. For that thing we will review it tomorrow morning. But currently we will review following things: what are main design principles of Java, what are main benefits of Java, what is so-called Java technology stack, what is Java virtual machine, what it does, how it works, how you execute Java programs, and which Java version should we use, and which integrated development environment should we use. So first, about principles, there are many programming languages which started as quick and dirty solution and then grow into more widely used programming languages. Typical example is, for example, Bash, scripting programming language in Unix-like systems, Perl, maybe also AWK or AWK, maybe also PHP, maybe also JavaScript. So such programming languages was developed usually by a single visionary, single developer who had to deal with one particular problem, and usually because of their optimism and inexperience, they decided that they actually will develop their own programming language which will do this better than all previous ones. And because of that, such languages usually lacks consistency and the same approach for similar but different things, etc. Java was not such programming language. Java was designed by committee. Many people collected together which started to design language from formal specification. So before Java as a language was actually built and developed, this design committee actually thought about state of art of programming languages and how this state of art should be improved. And so what this committee decided, and currently this design committee is called, I don't remember, it is open source community which uses similarly to RFC standards, request core comments, they have issue management to discuss all these issues about Java programming languages, and so many people decide how to do this. And if you know something about design, when anything is designed by committee, not by single visionary person, usually it is quite good enough, but it may have different compromises between different parties, and usually it's not something very revolutionary, something very exciting. So in Java is some of such programming languages, and what this committee decided is that first Java will be object-oriented programming language, which means that everything you will need to build together will talk about so-called objects, or which is some kind of structured data together with methods how you can handle them and interact with them. And in Wikipedia, this approach is also called nouns over verbs. So you do not start with instructions what to do, but you start with instructions what you have. So you have something, some structured data, and for example for business administration, business process management systems, these are claims, orders, customers, warehouses, locations, things which you name as a nouns. And then you do some activities. There are different paradigms, different ways how to do this. You may start with activities, what you need to do. And then these nouns or structured data are just side effects of invocation of these activities or functions. Then everything is structured into packages which contain these classes, and we will talk in details about class, of course, when we talk about syntax. Then you have two types of data, primitive data types and objects, and these are handled differently. They have different properties. Primitive types are smaller, faster, not so developer friendly. Objects are heavier, fatter, bigger, but more developer friendly. Java has built-in support for networking. Java has built-in support for multi-threaded programming, for safe memory management, and of course it is programming language which you write once and run everywhere. So it allows you to do this. It doesn't mean that you will always decide to develop programs in a such way because of time constraint and other limited resources you may have. Also, Java introduced standardized error handling using exceptions. It solved problem with scalability. How can you make things to work much faster using multiple threads and better automated management of resources of your virtual machine which runs inside physical machine. It is static typing, not duck typing or dynamic typing, which is a little bit harder for beginners, but it is very useful for large integrated projects. It executes dynamically. You can dynamically load and unload dynamic libraries, which you may use for some time and then free up your virtual memory to do something else. And it has different exchangeable implementations. What is important about Java is that everything is developed as open source software. So open source in general means everybody can get free copies of it, everybody can see source code of it, everybody can make changes for it and distribute their own copies. And Java was first developed by Sun Microsystems, which was bought by Oracle, so now it is mostly managed by Oracle, but it consists of several things. First, it is programming language, which is designed by this Java community process, where everybody can participate who is not lazy and who have enough time to work on it, because of course when you participate in such process you are not paid employee. You may be paid by your employer like Accenture or Oracle or whatever, but this community process is just sabiedriskais darbs, voluntary job. So they are developing language features or language itself. They implement one of implementations how this language can actually work, and they also implement different kind of development tools around it. Particularly about Java packages, there are two different things you need to know. One is Java runtime environment, which is needed when you need to run Java application in your computer, whether it's your desktop or laptop or server or whatever. So this is smaller set of all necessary tools and things. A larger set of tools and things is called Java Development Kit, or JDK in short, which also has tools to compile, debug and test your developed application. So all of this is open source with quite permissive open source license. So you don't need to pay royalties to develop, run or use anything of these tools. It is still trademarked, so trademark of Java belongs to Oracle currently. So if you create your own fork of Java implementation, you cannot call it Java, you should call it something else. For example, SAP, as a large company for business process management tools, they use very similar implementation of Java, but they call it Apex because it's different from standard Java. And there are still some discussions what can be copyrighted and what cannot. For example, you may look on case of Oracle against Google or Google against Oracle about Java API reused in Android operating system. And so what is this Java platform stack? If you look on high perspective, you use Java as a programming language, but to use this Java of programming language, it cannot be somewhere inside vacuum in empty place. So it needs real tools, real applications to run somewhere. And what is basis? First basis is Java Virtual Machine, which allows you to run your Java applications independently of actual hardware and actual software. And here when you talk about Java, term like platform is quite widely used. And what is platform? In general, platform is unique set of properties of hardware and software and if you have unique hardware like IBM PC compatible plus Windows, this is one platform. If it is plus Linux based system, it is different platform. If it is like Apple M1 plus MacOS, it is one platform. It is IBM PC plus MacOS. Again, it is different platform. So on the same compatible hardware, there may be running different operating systems, and there may be like the same hardware, but if this hardware is used by different operating system, and here I mean mostly operating system, then again it's different platform. And for each of these unique set of hardware together with operating system, because Java Virtual Machine relies on features provided by operating system quite a lot. And remember, one of the very important parts of operating system is to provide common set of libraries that for recurring tasks like managing file system, managing network and graphical displays and terminal, etc., may be reused by many other applications, so they do not need to include everything of these activities in their code itself, but they can rely on these features of operating system. So here for each of these platforms you have different Java Virtual Machine, but when you have these different Java Virtual Machines for different platforms, here you can always use the same Java application and you don't need to care so much about different operating systems running on different hardware. So here you have this virtual machine. In older times this Java Virtual Machine was called, I don't remember, but current one is called Hotspot. And then you have different kind of Java libraries, which are compressed as Java archives or files with extension .jar, where jar means Java archive. And then you have different other libraries, which are more intended for specific purposes, like working with networking, input-output, XML files, etc. Then you have different kind of frameworks and toolkits. And what is framework? Framework is collection of libraries with some guides how exactly you should use these libraries together. JavaScript programming language is very famous with very different frameworks, because JavaScript as a programming language itself is quite inconsistent and quite strange. And then you have different kind of tools which you also install together with your GRE or GDK package, like executables. Java is actual Java Virtual Machine, Java-C is Java Compiler, Java.docs is Java Document Generator, jar is archiver for Java files, Java is the compiler, and other things. And here you also see what is GRE, and everything else is also GDK. And some of you may also be interested how this goes together with Android operating system. And if you look in very general things, then everything is completely different besides Java as a programming language. So somewhere here we can also say ARM architecture, and this M1 processor for Apple is more or less compatible with this ARM design of processors. Okay, ARM plus Android. So what is this particular platform? If you look it in different, so here is hardware at the bottom and here is software at the top. So in hardware you can have these different architectures of your computer design. Personal computer, ARM based computers, MIPS, and other. These are so-called RISC architectures. This is mostly CISC, but they are overlapping features. And then maybe some other supercomputers like Cray and some other very different hardware. And then particularly for Android operating system, they run mostly on ARM based architecture, but some mobile phones or mobile devices may also have this MIPS architecture or IBM PC compatible. If it's IBM PC compatible, you may see x86 shown somewhere in the name of this architecture of this standard. And so they have Linux as a set of device drivers and low-level operations from operating system like network, file system, and graphical display, etc. And then on top of this you have Java Virtual Machine, which currently is called ART from Android runtime, and then you have your Java apps. And this is how Android looks like. If you have IBM PC compatible computer like my computer and probably yours, and you have Linux operating system running on it, this part is very the same between Android and, for example, your Linux based operating system. But difference here is that you have large set of GNU utilities, where GNU is this operating system, GNU is not Unix. Then for graphical display management you have x.org, framework, libraries, etc. And then other things like LibreOffice, etc. And I would say these are native apps. What means native apps? Native app can be executed like this. This mousepad is native application. It doesn't need virtual machine to run it. So these native apps may be LibreOffice, maybe Java Virtual Machine, which executable is just called Java, and other things. And then if you run Java Virtual Machine, then you may have Java apps only as some part of many other applications you may run. And of course, if you run this on IBM PC, but with Windows, your architecture looks a little bit different, because for Windows you have Windows drivers here, and here you have Windows libraries, and here you have this Java Virtual Machine and other tools. So if you run Microsoft Windows, then hardware is the same, but this stack how you manage your hardware, how you then use this service from hardware are completely different. So that's about Android operating system. Google decided that Java is actually not bad programming language to be used to develop their mobile operating system. And to make their efforts less, they decided quite rightly to use Linux kernel for device drivers and other things. And so they completely rewrote everything from Java design. So in general, Google used design of Java programming language, but they re-implemented it from scratch mostly for legal reasons, but also for technical reasons. And so even though programming language is the same, what can be used in Android, this stack between hardware and service you are using and libraries you are using are quite different. So, and then what Oracle says about Java, so that you can start quickly, you don't need to write much of code, it's better. You can avoid platform dependencies because you write once, run everywhere, at least in theory. And you can distribute this software, but real developer says that first important part is that it is open source. So you don't need to deal with royalties, you don't need to pay any money, you don't need how much of installations you have installed somewhere, so you can use it very freely. Then Java compiler is one of the easiest compilers you can use if you have some experience with C, which was mostly used programming language before Java. Then you should know that C compiler like GCC, because CLang was not invented at that time, is much harder to use than JavaC. So it has standardized API and very consistent API in difference with other programming language. It may be slow, but it can be made high performing because of multi-thread programming. It has open source IDEs and quite standardized like NetBeans, Eclipse, IntelliJ IDEA. It has very great backwards compatibility. If you know something about Python programming language, actually there are two different programming languages. One is Python version 2 and another is Python version 3. Because their community was not so great, they couldn't allow to overlap support for this backwards compatibility, and therefore for Python and also for Ruby this compatibility between versions is much harder to deal than with Java, and Java is enough mature as programming language and also it innovates enough. Then what is very important are so-called JVM languages. So standard Java works following: you have your Java source code, you compile it, you get your Java class and you run it inside virtual machine. But there are other programming languages which still runs inside Java virtual machine, but languages itself are different. Most prominent ones are Groovy, Scala, Kotlin, and what else? Maybe, for example, Clojure. These all are different programming languages, so you write different text when you program into them. They have different compilers because each of them compiles. But when they create this Java class is compatible with that Java class compiled from standard Java, and then you run inside Java virtual machine in absolutely the same way. And so these programming languages, where was I? Are called JVM or Java Virtual Machine languages. So these are not Java, but they still reuse all this great infrastructure of Java runtime, and probably currently most popular one may be Kotlin for Android. Groovy is quite popular for Gradle building system, which is used in Android projects. Scala and Clojure, they have their own benefits. For example, these are great programming language for functional programming. And that means that you may decide to use different programming languages which are more modern than Java, because Java is invented in 1995, so it's more than 25 years old programming language. Of course, it still develops, but some of design decisions which were put in Java still should persist because of backwards compatibility. So you can use different programming languages and still run this compiled source code together with Java as a programming language. One of questions may arise why Java didn't take Vault as a storm, and I think one of the important reasons was that Microsoft Windows operating system did take Vault as a storm, and initially in this Java development consortium also Microsoft participated in this consortium. All large IT companies at that time participated in it, like Oracle, Sun Microsystems, IBM, Microsoft, SAP, and some smaller ones like Red Hat and other things. But Microsoft was not happy about some of design decisions for Java, about how much features it should include, how exactly it should run in Microsoft Windows, and they developed their own programming language called C# with their .NET framework, and after that they used all technically possible, sometimes illegal approaches to make the life of Java developers harder if they are using Microsoft Windows operating system. So I think that was one of the biggest reasons why it was not #1 programming language. But if you look on two different statistics, one is TIOBE Programming Community Index, which mostly checks how much activities you are doing by googling something, etc. Then Java is the most popular programming language. If you look on RedMonk statistics, which mostly looks on different kind of open source repositories, then the most popular programming language is JavaScript, and it shares only part of name with Java. So JavaScript related to Java is as similar as car is related to carpet. So only some part of words are similar, but concepts and syntax of course is similar, because both of them took syntax from C programming language, but otherwise there are quite a big of differences. So JavaScript is completely different, and because JavaScript as programming language is not so organized as Java, even though JavaScript is for some measures is the most popular one, what people are actually using, they are using different kind of JavaScript frameworks like Node.js, like Atom.js and other JavaScript frameworks, which hides these inconsistencies of JavaScript language. So, what is Java Development Kit? Java Development Kit consists of different kind of developer tools. The most prominent ones you should know is JavaC, which is Java compiler, text as an input, binary code as an output. For those of you who are not so experienced, what means binary? Binary means that if you look on everything in binary, you can organize everything just by zeros and ones, because this is a minimum amount of digits you need to describe something. And of course you can group something somehow then together. For example, you can make decimal system which 10 digits, hexadecimal system with 16 digits, etc. But these are just ones and zeros. And that would be binary file. That probability that you will see just 1 or 0 is pretty much 50-50% chance. And without knowing proper structure about this, you just see something like random noise of these zeros and ones. If you know something about internal structure, you may see that there's actually something. But if it's text, then probability about these zeros and ones is not just 50-50, because some of these groups of zeros and ones are assigned as letters. And when you get some binary file, so if you look on some binary file, with some binary editor, here these zeros and ones are grouped into hexadecimal digits, so this means that numbers are in range from 0 till to 9, and then from A till to F. And in total there are 16 digits instead of 10 digits. Why? Because 16 is much better number for computers which are binary based than 10 numbers. And for purely binary file, you just see this something like random numbers here, but sometimes you can easily also see some text. But if you look on some text file, and you calculate and you use some of these numbers as a text representation, you can quite easily read something here as a text. So that is text document. If you are more curious, then you should learn something about ASCII table. So this is how these numbers are assigned to the letters, and we may talk in more details how you describe as the numbers non-Latin characters later. So that is what is Java compiler. So, and then Java is interpreter or bytecode of the Java virtual machine which executes this compiled file. And then other tools like Java.dots for documentation, creation, jar for packaging, GDB for debugger, etc. So then in this particular GDK, you are using one particular version of application programming interfaces or set of methods you may use inside your Java program. Then you can deploy it in different ways, like as a web archive or WAR files or jar files. Then you can use different kind of frameworks and toolkits, for example for graphical applications like JavaFX or Swing, and different kind of libraries which are not maybe or may not be part of a Java standard. So then, what is Java Virtual Machine? Java Virtual Machine is executable file, so you can call it just by Java. And if you call it without any parameters at all, it shows you following message, that it should be run in blah 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 following way. And it confirms the formal specification of this Java Virtual Machine. So if you can implement Java Virtual Machine by yourself, if you are not lazy and you are crazy enough. And then you may ask Oracle and this Java development community to test it and accept it as yet another implementation of your Java Virtual Machine. And here is this process how you run your Java application. You start with text document like in Mousepad or Notepad in Microsoft Windows, which is plain unformatted text file. For more modern Javas, it also may include non-Latin characters. For old school Java, only Latin characters. Then you compile it, you create this binary file with extension .class. So here is text with extension .java, here is binary file with extension .class, and then you have different Java virtual machines for different platforms, and if you develop it correctly, it may run in the same way in all these different platforms, including Android operating system and other operating systems. And this Java virtual machine provides following things. It allows you to load your code dynamically. It verifies it. If it is latest and greatest hotspot Java virtual machine, it does actually funny things. It recompiles this .class file into native application for performance reasons. For example, first it was introduced by Android operating system for their Dalvik virtual machine, but now this Java hotspot virtual machine, which we are using for personal computers, also does the same way. So what is actually shown here as a more general case, actually .class is maybe recompiled again to native application, which can be run as a native application without this direction and monitoring of Java virtual machine, and then executed. So then it executes it, but it also checks how memory is used, how it's executed, etc. etc. So this compilation to the native code is quite new introduction in Java, so nothing wrong will happen if you will just ignore that part. And then what is also important, that internal memory of Java applications is managed automatically, so you don't need to care about reserving resources or memory and releasing these resources. And because Java relies on operating system, it works something like this. So if you look on hardware, you have two different kinds of memory. You have random access memory, which is fast but small because it is expensive. And this is chipset. And then you have either hard disk drive, which is magnetic drive, where you have aluminum plates with some rust on them, and then you read write by changing magnetic field on this rust on top of magnetic plate, or you have solid state disk, which is also a chipset. So, but it is slower, but large and less expensive. And what does all modern operating systems? They create so-called virtual memory, which takes entire available random access memory together with some part of your persistent memory. So if this is random access memory, we can also generalize it and call it persistent memory. Not everything, but usually you have so-called swap file or partition inside this disk. So file is smaller part of partition, and partition is smaller part of disk itself, but so you have disk which may be containing many partitions, and each partition may have a file system with many files inside it. And so everything here is this virtual memory. And then for Java, some part of this entire virtual memory of operating system can be used by Java. And again, some part of it may consist inside physical random access memory, some part may be into this swap disk. And then this memory contains two important parts: stack and heap. Stack is better organized part of memory which runs fast. We will go in details later, but in general you start with highest possible memory cell and you go down. And heap is less organized, works slower, and you should try to write your code in such ways that most of it is located in stack part of memory, not heap. And here you just put everything in a heap, like you put logs in a heap. So every free space which can be used for your data, what you need to hold, just goes up. And we will go in details about this later, for example when we talk about objects, etc. So on all these things are organized automatically. You don't need to do like allocate or allots or mallots like in C, or free like in C, so everything is working automatically. Then it counts program counter, how much your program has executed so far. It also has a layer how you interact with actual resources of operating system, because when this Java virtual machine runs, it still relies on many services provided by operating system, and so that is also done automatically. And it also has this virtual processor and just-in-time compiler and any other things to actually execute this code. So how Java program starts? If you write something in scripting languages like for Bash programming language, and you run it, then execution starts from the first line which is executable, and in this case here. But for Java, execution doesn't start there. In scripting language it will be something like, what was in Bash? I don't remember details. So in Java, actual execution starts with place this following line: public static void main string args, and I will go in details later. So you may have many methods declared or described in your source code, and your execution will start from this main method. And because Java is very verbose programming language and very precise, every word here is important. Only word what is not important here is this here, because it is name of your variable declared. So it can be called whatever you like, A, B, C, D, blah blah blah. So, and if your Java source code has such line with some differences for this named variable here, or when we talk about exceptions, we may also add throws blah 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 here, then execution will start with the first line of code from here. And if we go a little bit ahead about programming tools, then for example here we can create some test project. So we can create a new class. Let's call very imaginative test, and we can generate public static void main string args this entry point. And then if you know something about Java already, something is not great with auto completion in my settings. And we can run it as Java application, and it will print it out here in the console. There may be Java classes which may be used as a library, dynamically loaded library. And you cannot run it as a Java application because it doesn't have this public static void main method which takes array of strings as arguments. It has different method. So if you go in integrated development environment, run as, you see something like run on server. We will not go in details about this, but it cannot be run as a Java application, but it can be run as a library. And now my project actually contains two different classes. test.java, which is Java application, but actual execution, how it will actually work, is coming from a different file. So in this case, my project consists of two different classes in source code, and if I look also in runtime, here in bin folder I have these two compiled classes, library.class and test.class, and if I run it, for example in terminal from command line, I say run Java virtual machine and execute test class for it. We see the same here in terminal, what we see here in our integrated development environment. So that's about libraries. So every execution in Java starts from this place. There may be Java classes which doesn't have such method. Then it may be started from somewhere else. And typical example is that if you rely on frameworks and you rely on libraries, this public static void main method, this entry point where it starts, is inside this framework, and then you just need to implement some other classes, because this execution starts from here and then it goes till to your class and executes some code in this main class, etc., etc. So starting point is always this public static void main method, but it doesn't mean that all your Java source codes will have this starting point, because if starting point is somewhere else and you rely on this starting point somewhere else, then you may have different set of methods and you run it differently. Typical example what you will see for next 2 weeks is JUnit automated test framework, because again these classes will not have main method, but they will be executed and called from main method somewhere in JUnit framework libraries. Other important part is class path in Java, which is saying how do you locate your libraries to deal with DLL. If you are more curious, I think there is Wikipedia entry for that. And it is very typical, was very typical for Microsoft Windows. Microsoft Windows named the dynamically loaded libraries with extension .dll. It is not so big issue with Unix-like systems like Linux-based systems and MacOS. And it's also no big problem for Java, because Java deal with DLL hell in following way. That if you have simple and primitive project, you may not care about class paths at all. You just name your classes in unique way and then you use them. But for more serious projects, we may need packages. And you see that here now I have two classes with absolutely the same name, test.java, test.java. But difference is that this test.java is inside package test and this is in so-called default package or no package at all. And now if I want, for example, to use I cannot use this library.java because as soon as I'm starting using packages, I can import only classes from named packages. So for simple stupid examples, I might not care with packages at all and class paths at all. Class paths means in which places you search for packages. But then I can import only classes for named packages, and all standard Java classes of course are located inside package, so I can use them. For example, then I need to create a copy, for example here of this library here. And now when I run it, it works absolutely the same, but instead of short named classes, I actually used classes in package test. And now if I want to use them, hopefully this will work. Okay, we will say here hello from we need to run it to compile it. And currently everything still works pretty nicely to us because all these compiled classes are in the proper place. But sometimes you need to do something like add class paths like Java, class paths in bin, test. So with this additional argument or parameter argument, I say that all other, this class and other classes should be searched in bin folder, starting from current folder. And we may go into more details later. And yeah, naming conventions for package is all lowercase letters, and usually what you see is that there is, and good style is that all your packages and classes are globally unique, to not have this DLL hell in Java world. And how you ensure that these are globally unique? For example, domain naming system for web resources like websites, etc. are already globally unique because in domain name system they allow you to register only globally unique domain names, and therefore you usually see quite frequently that for commercial entities like Accenture, IBM, Oracle, you see that names of these packages are com.oracle, etc. And for some historical accident, for DNS naming system, you have wrong order of superiority of resources. For example, .com, even though it's in left part, is most important part, and then company, and then .project. So orderness comes from left to right, but for Java packages it is in proper alphabetical order. Your package, if you use your DNS name for your packages, is like com.company .project .something class. Or if it's organization, it may be org. If it's nothing, for example, for IaaS, it will be gtm.something. So now about which package vendor and which Java. Because Java as a standard is royalty free, everybody who is not lazy can follow and use it. In difference with C# programming language and Microsoft.NET, there are many Java implementations, set of tools, virtual machines, all these things coming from different vendors. Question may arise which one to use. De facto implementation coming from this Java community is a project called OpenJDK. So in older time it was mostly led by Sun Microsystems, currently Oracle. But this OpenJDK currently is maintained by all these large companies: Oracle, IBM, SAP, Red Hat, Amazon, Microsoft, and many others. Yeah, and including Microsoft, because Microsoft is back to Java community process, because Java is very popular for many different business areas. And so they all together develop OpenJDK. And if you use Linux-based operating system, in most of cases you also install OpenJDK as a standard implementation of Java on your computer. But you may get it rebranded and added. For example, Oracle Java is OpenJDK with some additions to this OpenJDK, which where these additions are not released as open source. So Oracle, for some reasons, have some addition to this standard Java, which is not released as open source. So for example, if you use Oracle Java, which are usually called Oracle Java Standard Edition, Enterprise Edition, and Mobile Edition, 3 different versions, it is mostly OpenJDK with some small differences for coming from Oracle. Also Red Hat, which was independent company developing and supporting services for its Red Hat Linux operating system. Now it's bought by IBM, so it's subsidiary of IBM actually. They have their own Red Hat / IBM OpenJDK called something like Red Hat OpenJDK or IBM OpenJDK. And then there may be some other vendors which you may be using. For example, if for some strange tool you are required to use their own, probably proprietary Java version instead of standard OpenJDK. And then if you use Linux operating system, then you usually use standard package manager, and you have different kind of GRE and GDK in these packages. And resolution is following, that particularly for Debian-based systems, for example, if we search we have quite large set of packages for Java runtime environment. Default OpenJDK version 11, 8, 11, 13, 14, 16, etc. And also for Java Development Kit, which is for development and debugging. And meaning for these packages is following: that if name of package starts with default, this means default version of either GRE or GDK for this particular version of Debian-based system. If it's headless, then it means no additional libraries are added which may be needed for workstation, like graphical interface, sound, maybe something else, I don't know. So usually you install headless version of your GDK or GRE on servers, where you don't need to interact with sound and graphical interface. So GRE is just runtime, GDK is development libraries, particular version inside it is particular version inside it. For example, you can install default GRE headless version on your remote server, or OpenJDK-8 just GDK, Java 8 development libraries. And then, for old school applications, to distinguish which particular Java version should be used, variable called Java_home, all capital letters, may be used to distinguish which particular Java can be used. For example, you may have installed more than single Java version on your computer, on your workstation, on server, whatever. And then you may say, for example, Java is blah 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 something else, to say that in this particular case your Java will be different. But with this old school approach, I do not know all the reasons why it was considered a bad approach. Some are because of security reasons, but in most of cases for modern Linuxes, and I'm not sure about BSD Unixes and MacOS, if you use native system, how do they resolve these issues with dependencies and versions. But particularly for Linux, it is done in following way. That maybe I have already installed more than one here. I already have OpenJDK 11 and 16. So, how it is done in Linux, particularly for Debian based, I'm not sure with Red Hat based Linuxes, because I have not worked with Red Hat based Linuxes like CentOS long time. So, if you run Java just by short name, what is happening here? That operating system searches where this executable file is located. And this location is declared in environment variable called path. So first, in my particular case, it's search for current path, which is shown as a dot here. Then home Valdis bin, then home Valdis video, home Valdis.localbin. So columns here are delimiters, and slash blah 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 are the limiters between folder, inside folder, inside folder. You may see something different in your virtual machine. And then folder usr local bin, usr local loskans bin, usr local bin, usrs bin, blah 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 blah. So it searches in this order to see where Java is found. And in this case, Java is found in this folder /usr/bin/java. But if we look detailed information what this file is actually so-called symbolic link to different place. And symbolic link in Unix-like systems is like shortcuts in Microsoft Windows. And because shortcuts in Microsoft Windows are implemented differently than symbolic links, they are actually not very widely used. But symbolic links are very widely used in Unix-like systems like BSD, MacOS and Linux. So, and if we look detailed information about this file in folder etc alternatives Java, it is symbolic link to different place here. Oops. Where was I? Where is my terminal? Here. And only this is finally executable. So Java /usr/lib/gvm/java-11-opengdk blah 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 is absolutely the same way because finally, after all these searches for executable files and resolving symbolic links to this Java virtual machine, in my computer it actually is located here. But if I look what else I have here, I have different Java version installed, Java 16, and I can rely to it directly using this full path in my file system. So Java version is default Java, but /usr/lib/gvm/java 16 opengdk amd64/bin/java version is this non-default version, and I can change this from version to version by changing this symbolic link. Something like this. So remove this symbolic link, and then for version 16, where was I? So now it points to different place, and now it is 16. And of course, changing symbolic link for beginners may be hard, and therefore you can use package manager if you use Debian based system. And for Debian based systems you can do it following. Is this written here? If not, then I know where to search. I can do it in following way. Update -alternatives config Java, and you say which Java version you want to use. I want to use Java 11. And you'll see that now the symbolic link points back to Java 11. So you may use Java Home environment, and some old school Java applications still require them, and if you are curious you can just Google for it. Why it's considered bad? I'm here, practitioner here. I just follow these new approaches as a system administrator and maintainer of systems. But if you want to be a real developer, probably you should know why this Java Home environment variable is considered bad. And there are many environment variables declared in operating system. For Microsoft Windows, I think it was a command called set. But for Unix-like systems, there are also two commands, set and env. And one shows also globally declared functions, and env only environment variables. And you can add your own environment variables here, like what your Java Home is, something like export Java Home. First we need to where it points, and export Java Home is, but I think it is still to here. And then you do something like this. Java home bin Java version. And you see that now it is version 11. If you export different variable like Java 16 here, and you see that it is version 16. So, but I skip it a little bit. I started about versions, now about which versions. So which versions you should use? Till to few years ago, all Java versions were equal. They were released approximately after new version was released approximately after 2 years. Each version was supported mostly for security fixes and bug fixes for at least 5 years. And that means that in each particular time, so here is time and here is version numbers, you could use older stable version, newer stable version, newest stable version of the Java, or older version, current and new version of Java. But starting with Java version 8, Java community learned from Linux community, and to speed up development process and to not drag too much back with backward compatibility, they introduced 2 different versions of Java, long-term support and short-term support. And Java 8 was first long-term support version of Java, which was initially supported at least for 5 years, actually it's even more than that. And then, approximately twice a year, after half a year, new shorter Java development versions were introduced with no large support time for bug fixes and fixing security issues like 9 and 10. So currently, I think the latest, greatest long-term support is Java 11, and then there are some newer ones as short-term versions, and we will be using Java version 11 as older stable version. And if you look on the release history, so Java 11 is last long-term support, and after some time I think Java 17 will also be long-term support version. When it will be released around September 2021, then if you want to switch to latest and greatest version of Java, you should use that. But if you are not testing environment, etc., for production purposes, you should use only these long-term Java versions starting from 8. And of course you shouldn't use older versions than Java 8, because these are very old, not supported anymore. Also, what is important about this backward compatibility, for example, Python is famous programming language with bad backward compatibility, because there are actually 2 different programming languages, Python version 2. something and Python version 3. something, because here these languages are quite different till to version 2 and starting to version 3. But for Java to have backward compatibility and also some innovation, they use following things. At first, for these long-term versions or older versions than Java, new version is introduced before older version has finished support. So support is overlapping, in difference with Python, where you have this flag day, so they either use this or that, but there is no overlapping things. And for each particularly new version, some new features may be introduced, but some features may be deprecated. What means? New features means something new, but deprecated means that somewhere here in some previous versions something was considered bad design, and it still works. You can compile it and run it, but for compiler you will see compiler warning that this particular approach actually is deprecated and shouldn't be used. but you will still be able to use it till this particular version will be supported. You will get security fixes and bug fixes, etc. But then when you will switch here, deprecated things will not be supported anymore. And again, some new features may be introduced, some new features may be deprecated. As it means that if you hit something deprecated in particular Java version because of your project and approach, you have approximately 5-7 years to deal with this until it will not be supported anymore. And this is a very great feature of Java, how Java support works, because when you switch to new version, if you didn't have any deprecation issues before that, you can switch very easily. Of course, for large complicated projects, some deprecation warnings may be. This means you will not have easy life to switch to the newer version because deprecation will not work anymore. And now about these development tools. Of course, you can write your source code in any development environment you like Notepad++ or just Notepad, but usually you like to use integrated development environments. And the most popular and most feature-rich are 3 Java integrated development environments called NetBeans, Eclipse, and IntelliJ IDEA. For beginners, NetBeans is the easiest one to use. It's not so feature-rich, but as far as I know, in some of universities, NetBeans is used as de facto development environment because it is easiest to install, easiest to use. For example, on your Linux-based operating system, if you are happy with how old it is, you just say sudo apt install NetBeans and you are done. If you are not happy with so old version, then you need to do what usually Windows user does, go to their website, download installer or package, extract it, etc. So the most feature-rich tool is Eclipse, and usually Eclipse is used for large-scale Java projects because Eclipse in general is something like Lego constructor. It has very advanced plugin systems, and if you need something additional in your development environment, probability that this additional thing will be developed as a Eclipse plugin is very high. And a few years ago, Eclipse was also used as a basis for Android Studio. But I do not know exact reasons, and both these tools, NetBeans and Eclipse, are fully open sourced. So you don't need to accept end user license agreements, you don't need to care about how many copies you are using. Everything is legally free to use. But for some reason, Google decided to switch their position and they started using IntelliJ IDEA as a basis for Android Studio. I think because the same company called JetBrains, who is developing IntelliJ IDEA, they also developed this Kotlin programming language. And Kotlin in many places are better programming language than Java, more developer friendly. And when we will talk about this in details and you will have practical exercise, you will see that de facto programming language for recent Android projects is not Java programming language but Kotlin programming language. It's still JVM language, it compiles to Java classes, but actual text, what you write as your software is not Java but Kotlin. I think that's one of the reasons why Google decided to use their tool as a basis, because then supporting Kotlin programming language for Android is easier for them. What is not so great about IntelliJ IDEA is that it is not fully open source. It has so-called open core model that some basic functionality or community version of IntelliJ IDEA is free to use, but every time you want to have some additional plugin, which for Eclipse you can usually get for free, for IntelliJ IDEA you usually need to get a licensed paid version of IntelliJ IDEA and or this plugin. So that's not so great for IntelliJ IDEA. I will use Eclipse as a de facto tool because it's fully open source, better looking fonts for Linux operating system, and I have used it not very regularly because I'm usually not working as a developer. I usually work as an administrator and maintainer, but I have used it for, I do not know, maybe not 20 years, but close to that, and therefore it's easier for me. And what important part about Eclipse is that it has good support for several projects inside the same IDE. Neither NetBeans nor IntelliJ IDEA has good support for several projects. That was very important for me when I worked as a tester. Still important for me when I working as a teacher. For NetBeans and IntelliJ IDEA, what they do, they actually open another copy of this tool, which takes more memory inside your physical or virtual computer, because in general, both these tools are intended to work only with single job project. So Eclipse is the greatest tool, which works in fastest way if you need to work with more than one job project at once. And that's about infrastructure of Java. Any questions or comments about that? If no, then we can make a break. 15 minutes, that would be. And then we all together will look in your practical exercise.